Got a networking exam breathing down your neck? Or hey, maybe you're just tired of wondering how the internet actually works. Well, you're in the right place. In the next few minutes, we're going to break down all the core concepts you need to know, and we'll make them simple and, most importantly, easy to remember. I mean, it really does feel like magic, right? You tap a button, and poof, your message just shows up on a screen thousands of miles away. Today, we're going to pull back that curtain. We're going to follow the exact journey your data takes, from the moment it leaves your screen to the second it arrives at its destination. So here's our game plan, broken down into 5 easy steps. We'll kick things off with the absolute basics, what a network even is. Then we'll look at the different sizes they come in. After that, we'll dive into how your data zips around, meet the cool hardware that makes it all possible, and wrap up with how we keep everything safe and sound. It's your perfect study roadmap. All right, let's jump right in with the most fundamental question of all. When we say computer network, what are we really talking about? At its heart, it's all about 2 things, connection and sharing. That's the key. A network is what lets your computer talk to your printer without a wire, or lets everyone in the house use the same Wi-Fi. Its whole job is just to let our devices talk to each other and share stuff. Simple as that. Okay, so we know what a network is. Now let's look at the different scales they work on. This is a really great way to picture how your little home network plugs into this giant global system we call the internet. First up, we've got the LAN, or local area network. This is the one you probably know best. It's your Wi-Fi at home. It's the network that connects all the computers in an office or school library. The keyword here is local. All the gadgets are in one physical spot. Now, take a step up and you get a CAN, a campus area network. And yeah, it's exactly what it sounds like. It takes a whole bunch of separate LANs, the one in the science building, the one in the dorms, the one in the library, and links them all together across one big campus. And finally, we get to the big one, the WAN, or Wide Area Network. This thing connects networks over massive distances. The ultimate example of a WAN? Well, it's the internet itself. It's just this ridiculously huge network of networks that covers the entire planet. Okay, so we've got these networks connecting everything from our room to the whole world. But how does a photo you send actually get from your phone to your friend's phone without getting totally lost? Well, it all comes down to a very clear set of rules. And those rules have a name, protocols. The easiest way to think about them is like the traffic laws of the internet. We need rules of the road to drive safely, right? Well, computers need protocols like TCP/IP to make sure all the data gets sent and received correctly. It's the shared language they all agree to speak. Now, here is a huge concept, especially if you're studying for a test. Networks don't send your email in one giant piece. That would be super slow and just clog up the whole system. Instead, your data gets chopped up into thousands of tiny little bite-sized pieces called packets. And each one of these packets acts like its own little digital postcard. Seriously, it's got a small piece of your message, and it also has the to and from addresses written right on it. This means they can all take different routes through the internet to get where they're going, and then they all get put back together in the right order at the end. It's pretty brilliant when you think about it. So we've got the rules, the protocols, and they have the method, the packets. But what about the physical stuff? What machines are actually doing all this work? Let's meet the team. First up is the router. If packets are the postcards, the router is like the main postal sorting office. It looks at the destination address on every single packet and makes a split-second decision on the best, most efficient path to send it on its way. This is the master traffic cop of the network. Next, we have the switch. Now, a switch works inside a single local network, like your office LAN, and it's way smarter than older devices. Instead of just shouting the data out to every single computer connected to it, a switch is like a really precise mail carrier, delivering each packet only to the specific computer it's meant for. So much more efficient. And last but not least, the modem. The name is just a mashup of modulator-demodulator, and its job is absolutely essential. It's a translator. It takes the digital language that your computer speaks and turns it into analog signals that can travel over old-school phone or cable lines, and then it does the whole thing in reverse on the other end. With all this data flying around the globe, security is obviously a massive deal. Like any highway, the information superhighway has its dangers. So how in the world do we protect our stuff while it's on this crazy journey? Let's do a quick lightning round to clear up 2 terms people always mix up. A virus is a bit of bad code that has to latch onto a program or a file to spread. It needs you to open that file. A worm, on the other hand, is a standalone troublemaker. It can copy itself and spread all over a network all on its own, no human help needed. So, what's our main line of defense? It's the firewall. The best way to picture it is as a security guard, or maybe a bouncer, standing at the only entrance to your network. It inspects absolutely everything trying to get in or out, and if something doesn't match the security rules, it's not getting through. And this image here really drives that point home. It's a literal wall of fire, a digital brick wall standing between your safe, trusted network and the wild, untrusted internet out there. It's your first and probably most important line of defense. So there you have it. We've gone from LANs to packets to firewalls. We've covered the what's and the how. But that kind of leaves us with one massive question, doesn't it? If protocols are the laws of the internet, who gets to write those laws? Who's in charge of this critical infrastructure we all rely on every single day? Well, that's a whole other can of worms and a fascinating topic for another explainer. Thanks for tuning in.